Greetings, engineers. Welcome to today's session. In this session, we'll be looking at the integral which is on your screen, which is the integral of sec⁵x to the power of 5 multiplied by tan x. And this is integrated with respect to x. So if we zoom in on the problem in this page, we can clearly see that we have a trig integration problem where we have a tan and a sec. And where we should start, it is not really obvious, but we have a task of trying to remember what do we know fundamentally, which might be able to assist us here. So there's a couple of things which I need you to remember. I need you to remember that when we find the derivative of tan, the answer is simply sec²x. And when we find the derivative for sec⁵x, the answer is simply tan x sec⁵x. So with this in mind, we need to figure out on our problem above here, how can we, because we know how tan is related to sec, how can we exploit or use this relationship to be able to solve this integral which we know which we have above? So there's one thing which becomes obvious. We should somehow do some substitution. Do some substitution of some form. More specifically, we will use the U substitution method to solve this problem. So if we look at the expression, we can try to rewrite it such that one aspect which appears on the expression becomes the derivative of another one. So let's outline that. So our aim is to write the integral. Very important. We want to write the integral such that one part of the integral can be derived to get the other part. Okay, so obviously parts of the integral must be products, or they must be quotients of one another. So if I quickly rewrite that, you will see that if I choose to say, let's take the sec and write it to the power of 4. So that we compensate, it means we need to put the sec here because there were 5, and we have the tan here, and then dx. So when we now observe this expression, we will come to an appreciation that this part here must have been a derivative of sec⁵x. That we can easily see. That part there must have been a derivative of sec⁵x. We know that. So which means in my expression, I need to look for the part and make it the u, which when I derive, I get that sec tan and that sec⁵x tan x. So clearly, what we derived was sec⁵x. So once I'm able to pick up what do I need to derive so that I get what part of the integral do I need to derive so that I get another aspect. Once I'm able to deduce that part of the integral, I will set it to sec⁵x. So the u, I will now set it to sec⁵x. But which sec⁵x are we specifically looking at? So the one which we have seen that it somehow relates with sec⁵, we are not going to chart. We're not going to touch. So essentially the sec⁵ which we are going to make the u is this one, which is inside the bracket. So if you have a look, we have now made our sec⁵ to be equal to u. So when we derive with respect to x, we get sec⁵ tan x. And if you look carefully, our du becomes sec⁵ tan x dx. So what does this mean? It means we can replace, or wherever we see, let's say this, wherever we see sec⁵ tan x dx, this can be replaced with du. And wherever we see sec⁵, we can go and replace it with u. So what does this mean? It means our integral becomes, we said our sec⁵ is u, and there was a power of 4. And we see that our expression has sec⁵ tan x dx. But we just found out now that that can be equated to du. So I can have du like that. So if you look carefully, I just have u to the power of 4 du. And when we integrate this, we should add a 1 and divide by 4 plus 1. Most importantly, we should add the constant. So if you look at our final answer, it becomes 1 over 5 u to the 5 plus c. However, we need to go and replace and substitute whatever which u was. So our answer finally becomes 1 over 5. Our u was sec⁵ plus c. This is the approach which we were supposed to take to be able to solve this problem, the u substitution method.